They called it the Kugo, the death ray, a beam weapon that could kill at a distance without bullets or explosives. Japanese scientists demonstrated it in front of military observers in 1943. They pointed the device at a rabbit 30 meters away, activated it. The rabbit convulsed, fell over, died within seconds. The generals were impressed. This was the weapon that could change the war. Invisible, silent, deadly. If it could kill a rabbit at 30 meters, surely it could be scaled up to kill American soldiers at 100 meters or more. Development was ordered to continue with maximum priority. 2 years later, when American forces captured Japanese research facilities, they found the Kugo prototypes. They tested them, examined the technical specifications, interviewed the scientists who built them, and they discovered something the Japanese military had learned too late. The death ray worked, but only on rabbits, at 30 meters, on a clear day, when everything was perfectly aligned against actual military targets. It was completely useless. This is the story of Japan's secret weapon program that promised to revolutionize warfare but delivered nothing except dead laboratory animals. How desperation in 1943 led to investments in impossible technology. How scientists were pressured to show results even when physics said no. How a weapon that worked in demonstrations failed in every way that mattered. But first, you need to understand why Japan was looking for miracle weapons in 1943. By mid-1943, the Pacific War had turned decisively against Japan. Guadalcanal lost, Papua New Guinea under pressure, American industry producing ships and aircraft faster than Japan could sink them. The material advantage was shifting overwhelmingly to the Allies. Japanese military leadership recognized this. Traditional weapons were not going to win the war. American production capacity was simply too large. If Japan continued fighting with conventional arms, eventual defeat was certain. Only technological breakthrough could change the equation. So they looked for breakthroughs, anything that might provide decisive advantage. Jet aircraft, rocket weapons, biological weapons, chemical weapons, nuclear weapons, and directed energy weapons, the death ray. The concept was not new. Scientists had theorized about directed energy weapons since the early 1900s. Tesla had claimed to have designed a teleforce weapon. Newspapers ran sensational stories about death rays. But no one had actually built a functioning device, or so everyone thought. Then, in 1943, a team of Japanese scientists at the Army Science Research Institute claimed they had succeeded. They had built a device that could kill living targets at a distance using focused electromagnetic energy. The principle was theoretically sound. Electromagnetic radiation at certain frequencies can cause biological effects. Microwave radiation heats tissue. Extremely high power levels could potentially cause lethal heating. If you could generate enough power and focus it tightly enough, you could create a weapon. The Japanese device used magnetron technology to generate high-power microwaves, the same basic technology that would later be used in radar systems and microwave ovens. But in 1943, it was cutting edge. The magnetrons were bulky and inefficient. They required enormous electrical power. But they worked. The prototype consisted of a large power supply, cooling system, magnetron array, and focusing dish. Total weight was approximately 1,200 kilograms. It required a dedicated diesel generator to power it. Setup time was over an hour. It was not remotely portable or field deployable. But it could kill rabbits at 30 meters. The scientists demonstrated this repeatedly. Military observers watched rabbits placed in cages at measured distances. The device was activated. After exposure of 20-30 seconds, the rabbits showed signs of distress. Within minutes, they died. Autopsies showed internal heating consistent. with microwave radiation exposure. The demonstrations were impressive. Here was proof that directed energy weapons were possible. The generals saw potential. If the range could be extended, if the power could be increased, if it could be made more portable, then perhaps it could be used against enemy troops. Funding was allocated. The program was classified at the highest level. Scientists were told to solve the engineering problems, make it more powerful, extend the range, reduce the weight, make it battlefield ready. The scientists tried. They built larger magnetron arrays, more powerful generators, better focusing systems. They achieved some improvements. Power output increased, but range did not increase proportionally. The inverse square law was unforgiving. Electromagnetic radiation spreads out as it travels. At double the distance, the energy is spread over 4 times the area. To maintain the same intensity at twice the distance, you need 4 times the power. To reach 60 meters instead of 30 meters, they needed 4 times the power. To reach 120 meters, they needed 16 times the power. The power requirements became absurd. The prototype was already using all the power a small generator could produce just to reach 30 meters. Scaling up to useful military range of 200-300 meters would require generators the size of small power plants. This was not portable. This was not practical. There were other problems. The focusing dish had to be precisely aimed. The target had to remain stationary for 20-30 seconds. Any movement reduced effectiveness. Any obstacle between the device and target blocked the beam completely. Rain, fog, or smoke degraded the beam significantly. And the range against human targets was even worse than against rabbits. Humans are larger and have more thermal mass. A rabbit weighing 2 kilograms can be heated to lethal temperature relatively quickly. A human weighing 70 kilograms requires much more energy. Early tests on human-sized targets showed that the effective range was actually less than 20 meters for lethal effect. 20 meters, that is pistol range. If your weapon only works at pistol range, just use a pistol. It is lighter, cheaper, more reliable, and does not require a diesel generator. The scientists reported these limitations to the military. The response was to push harder. Find a way to increase power, improve efficiency. This weapon was critical to Japan's war effort. Failure was not acceptable, but physics is not negotiable. You cannot increase power indefinitely with 1940s technology. The magnetrons overheated. The generators could not produce more power. The focusing systems were already optimized. There was no breakthrough coming. The weapon had fundamental limitations that could not be overcome. By 1944, the Kugo program was consuming significant resources while delivering no useful results. Scientists were demonstrating kills at 30 meters. Military wanted kills at 300 meters. The gap was unbridgeable. Some scientists privately believed the program was impossible. But criticizing a military priority program could be career-ending or worse. So they continued working, ran tests, wrote reports, showed incremental improvements, and hoped that eventually the military would recognize reality. American intelligence learned about the program through various sources. Signals intelligence picked up communications mentioning special weapon research. Decoded messages referenced electromagnetic systems. POW interrogations provided fragments of information. By 1944, American analysts knew Japan was researching directed energy weapons. The assessment was skeptical. Directed energy weapons were theoretically possible, but practically very difficult. American scientists had looked at similar concepts and concluded they were not feasible with current technology. The belief was that Japan might have laboratory prototypes, but nothing battlefield ready. That assessment was correct. When American forces captured Japanese research facilities in 1945. They found the Kugo prototypes. They were tested by American scientists who confirmed they worked exactly as Japanese reports had described. They could kill small animals at short range. They were completely useless as military weapons. The captured documents told the story. Scientists had reported the limitations clearly. Military leadership had ignored those limitations and continued demanding improvements. Resources had been wasted on a program that could never deliver useful results. One American scientist who examined the Kugo wrote in his report, "The Japanese death ray is an impressive demonstration of microwave technology. As a weapon system, it is worthless. The power requirements and range limitations make it inferior to a rifle in every meaningful way. This program consumed resources that could have been used for practical weapons development." That assessment was harsh but accurate. Japan had spent 2 years and significant resources on a weapon that could kill rabbits but not soldiers. Meanwhile, American scientists were developing radar systems, proximity fuses, and nuclear weapons, all of which actually affected the war's outcome. The Kugo program was not the only Japanese miracle weapon that failed. There were many others. Jet aircraft that never reached production, rocket weapons that were unreliable, biological weapons that were uncontrollable. Each represented hope that technology could overcome material disadvantage. These programs shared common problems: insufficient resources, rushed development, political pressure to show results, scientists who knew the truth but could not say it, military leaders who believed in miracle solutions, and underlying all of it, the desperation of a nation losing a war. The death ray story is almost comical in retrospect. Scientists killing rabbits while claiming to develop a battlefield weapon. But it was not funny to the people involved. They were under enormous pressure. Failure could mean disgrace or worse. So they continued demonstrating what was possible while knowing it was not enough. Some Western accounts have mocked the Kugo program as evidence of Japanese scientific incompetence. This is unfair. The science was sound. The engineering was competent. The problem was not incompetence. It was impossible requirements combined with insufficient technology. American scientists examined the same concepts, concluded they were not feasible, and moved on to other projects. Japanese scientists reached the same conclusions, but were not allowed to move on. They were told to make it work regardless of physics. That is the real lesson of the Kugo. Not that Japanese science was inferior, but that political pressure can force smart people to waste time on impossible projects. When military leaders demand miracle weapons and will not accept no for an answer, resources get wasted on programs everyone knows will not work. The scientists working on Kugo knew it was not going to change the war. They continued anyway, because that was their duty. They produced reports showing incremental progress. They demonstrated successful tests on appropriate targets. They did not lie about capabilities, but they also did not clearly state this will never be a useful weapon, because that would end their careers. This dynamic exists in military research programs even today. Political leaders want advanced capabilities. Scientists know what is possible with current technology. Sometimes the two do not align. Scientists can either clearly state limitations and risk career consequences, or they can show progress on possible aspects while downplaying limitations. The Kugo scientists chose the latter. They showed they could kill rabbits at 30 meters. That was true. They implied this could be scaled up. That was less true. They did not explicitly state that scaling up was impossible with available technology. That statement came only in captured documents after the war. Could they have been more direct? Perhaps, but consider the context. Military police were monitoring research facilities. Defeatism was punishable. Questioning military priorities could be dangerous. Scientists did what scientists have always done under authoritarian regimes. They provided technically accurate information while avoiding politically dangerous conclusions. The American assessment after capturing the Cougar was that it represented competent work on a fundamentally flawed concept. The magnetron technology was sophisticated, the focusing system was well designed, but the mission requirements were impossible to meet. Modern directed energy weapons exist. The U.S. military has deployed laser systems that can destroy drones and missiles. These systems are effective because they use solid-state lasers with focusing systems far more sophisticated than 1940s technology. And even modern systems have significant limitations. They require enormous power. They are affected by weather. They have limited range. The Japanese scientists in 1943 were trying to build something that barely works even with 21st century technology. With 1940s technology, it was hopeless. They knew this. They could not say this. So they built death rays that killed rabbits and hoped someone would eventually acknowledge reality. That acknowledgement came only after Japan's surrender. American intelligence reports concluded the Cougar program had no military value. The prototypes were examined, documented, and eventually scrapped. The scientists who worked on them were interrogated and then released. No war crimes charges. They had built a weapon that did not work. That was not criminal, just wasteful. Some of those scientists went on to productive careers after the war. Their microwave expertise was valuable for radar development and other applications. The Cougar research, while useless as a weapon, did advance understanding of high-power microwave systems. One former Cougar scientist interviewed in the 1970s was asked about the program. He said, "We knew the death ray could not be made into a practical weapon. The power requirements were too great. The range was too limited. But the military wanted results. So we showed them rabbits dying at 30 meters. That was what we could deliver. They wanted to believe it could be scaled up. We did not explicitly tell them it could not be." That statement captures the entire program. Scientists doing what was possible, military believing what they wanted to believe, and physics refusing to cooperate. The death ray became a footnote in the history of failed weapons programs. It is mentioned in books about World War II secret weapons, usually for a paragraph or two, sometimes with photos of the prototype, always with the conclusion that it was an interesting failure. But the story deserves more attention, not because the weapon was important, it was not, but because it illustrates how desperation drives poor decisions, how political pressure can force waste of resources on impossible projects, how smart people can be compelled to work on things they know will not work. These dynamics are not unique to 1940s Japan. They exist in every military research program. Politicians want capabilities that do not exist. Scientists know what is possible. Sometimes what is wanted and what is possible do not align. The question becomes, do scientists clearly state limitations and risk consequences, or do they show progress on possible aspects while avoiding hard truths? The Cougar scientists chose to show progress. They were not lying. The death ray did work. On rabbits, at 30 meters, in ideal conditions. Those limitations meant it was militarily useless, but stating that clearly was politically dangerous. So they demonstrated what worked and let observers draw their own conclusions. This was not unique to the death ray program. Similar dynamics affected other Japanese secret weapon programs. jet aircraft programs that could not get enough rare metals for engine production, rocket weapons that had insufficient guidance systems, biological weapons that were too uncontrollable to use. Each program had scientists who knew the limitations but could not clearly state them. The result was waste. Resources spent on programs that could never deliver useful results. Those resources could have been used for incremental improvements to existing weapons, better aircraft engines, more reliable torpedoes, improved radar, practical improvements that might have extended the war. Instead, resources went to miracle weapons, death rays, jet fighters, super battleships. Each promised to change the war with one technological breakthrough. Each failed to deliver. And collectively, they consumed resources that could have been used more effectively. This is the danger of miracle weapon thinking. It promises easy solutions to hard problems. It suggests that one breakthrough can overcome fundamental disadvantages. It is seductive. It's also usually wrong. Wars are won by logistics, training, industrial capacity, and steady incremental improvements in equipment and tactics, not by miracle weapons. The few cases where single weapons had strategic impact, nuclear weapons being the obvious example, required massive resource investments and were not actually surprising breakthroughs. They were the result of years of work by thousands of people. The death ray was not that. It was a small program that promised much and delivered little. It killed rabbits, that is all. It consumed resources, it gave false hope, and it changed nothing. The Japanese military leaders who believed in the death ray were not stupid. They were desperate. They needed something to change the strategic situation. Conventional weapons were not going to win the war, so they looked for unconventional solutions. Death rays seemed possible. Scientists demonstrated partial success. Hope was maintained far longer than it should have been. This happens in losing situations. When conventional approaches are failing, unconventional approaches become attractive. Sometimes this leads to genuine innovation. More often, it leads to waste on impossible projects. Distinguishing between the two is difficult when you are desperate. The American atomic bomb program was a similar gamble. Enormous resources invested in unproven technology. It succeeded, but it might not have. If nuclear physics had worked out slightly differently, the Manhattan Project could have been an enormous waste with no useful result. The difference was not just better American science, it was also luck that physics cooperated. The Kugo program was unlucky, not in the sense that the science was flawed, but in the sense that the mission requirements were impossible to meet with available technology. If the military had wanted a device that could kill small animals at 30 meters, the program would have been a success. But they wanted a device that could kill soldiers at 300 meters. That was not achievable. No amount of clever engineering could overcome the fundamental physics. The scientists knew this. They could not say this clearly. So they worked, demonstrated, reported incremental progress, and hoped that eventually reality would be acknowledged. Reality was acknowledged after the war, after the resources had been wasted, after the opportunity cost of not developing practical weapons had been paid. The death ray that actually worked, but only on rabbits, at 30 meters, in perfect conditions, when everything was precisely aligned. Against actual military targets, in actual combat conditions, at useful ranges, it was completely worthless. The Japanese death ray that actually worked, until anyone tried to use it for anything real. Then it did not work at all. That is the story. A miracle weapon that was not a miracle. A death ray that killed rabbits. A program that consumed resources and delivered nothing except a cautionary tale about desperation and impossible promises. They called it the Kugo, the death ray. It worked until it did not, which was always. The technical specifications of the Kugo reveal both impressive engineering and fundamental limitations. The magnetron array could generate approximately 5 to 10 kilowatts of continuous microwave power at a frequency of around 10 GHz. For 1943 technology, this was remarkable. Modern microwave ovens use about 1 kilowatt. The Kugo was generating 5 to 10 times that much power. But spreading that power over distance destroyed effectiveness. At 30 meters with a focusing dish, the power density at the target was approximately 10 to 20 watts per square centimeter. This was enough to cause lethal heating in a small animal over 20-30 seconds of exposure. At 60 meters, the power density dropped to 2.5 to 5 watts per square centimeter, not enough for lethal effect in reasonable time. At 120 meters, it dropped further to less than 1 watt per square centimeter. At that power level, you would barely feel warmth if you walked into the beam. To achieve lethal effect at 200 meters, the effective combat range for small arms, the Kugo would have needed to generate approximately 400-500 kilowatts of continuous microwave power. With 1940s magnetron technology, this was impossible. The magnetrons would have melted. The power supply would have been enormous. The cooling system would have required industrial-scale water pumps. These were not engineering challenges that could be solved with better design. They were fundamental limitations of the technology. The scientists knew this. Their internal reports documented it clearly. But external reports were more optimistic, emphasizing achievements rather than limitations. One captured report stated, "Successful demonstration of lethal effect at 30 meters. Further development expected to extend range." This was technically true, but it omitted that extending range by even a factor of 2 would require quadrupling the power, which was not feasible. The focusing system also had limitations. The microwave beam could be focused to a relatively tight cone, but not to a laser-like point. At 30 meters, the beam diameter was approximately 1 to 2 meters. This was acceptable against stationary rabbits in cages. Against human soldiers who could move, it was problematic. A soldier who noticed the device could simply step sideways out of the beam. The exposure time required for lethal effect was 20 to 30 seconds. That is an eternity in combat. Any competent soldier would take cover or move out of the beam path long before lethal exposure occurred. There was also the problem of aim. The device had to be precisely pointed at the target. A difference of a few degrees at 30 meters meant missing entirely. With no visible beam, aiming was difficult. Later versions included optical sights, but these required the target to remain stationary while the operator aimed and activated the device. Battlefield conditions made all of these problems worse. Smoke from explosions or fires blocked the beam almost completely. Rain and fog degraded it significantly. Dust in the air scattered some of the energy. Any solid obstacle, even thin wood or fabric, provided complete protection. A soldier behind a tree was completely safe. A soldier in a trench could not be engaged. A soldier wearing thick winter clothing had some protection from the heating effect. The weapon was essentially useless against prepared defensive positions. The power supply was another major limitation. The prototype required a 20-kilowatt diesel generator running continuously. This generator weighed approximately 400 kilograms and consumed fuel at a high rate. The noise was substantial. The exhaust smoke was visible from a distance. Any enemy force within a kilometer could hear and see the generator running. Mobility was impossible. The entire system, including generator, magnetron array, focusing, Dish and cooling system weighed over 2,200 kilograms. It required a truck to transport. Setup time was over an hour. Once positioned, moving it to a new location required breaking down the entire system. Compare this to a machine gun. The Browning M1919, standard machine gun in American service, weighed 14 kilograms. It could be carried by one soldier. It could be set up in under a minute. It could fire 500 rounds per minute to a range of 1,000 meters. It required no power supply, no cooling system, no focusing apparatus. The death ray was inferior in every practical measure: range, lethality, mobility, reliability, ease of use, cost. A machine gun was better in all respects. The only advantage the death ray had was that it was silent and produced no visible projectile. But this advantage meant nothing when the weapon could only kill rabbits at 30 meters. Japanese military observers who saw early demonstrations were impressed. They saw technology that seemed advanced. They imagined what it might become with further development. They did not fully understand the physics that limited its potential. Senior officers who had not seen the demonstrations received reports of successful tests. Death ray demonstrates lethal effect at measured range. This sounded promising. They allocated more resources, ordered accelerated development, and waited for the miracle weapon to change the war. The scientists knew the miracle was not coming. Some tried to communicate this. One report from 1944 stated, "Current maximum range is 25-30 meters. Achieving a 100-meter range would require 10x power increase. Achieving 300-meter range would require 100x power increase. This is not feasible with available technology or foreseeable improvements." That report was clear enough, but it was buried in technical documentation. Senior officers may never have read it. Or if they read it, they may not have understood the implications. Scientists were saying, "not feasible." Officers heard, "difficult," and assumed more effort would solve the problem. This communication gap is common in military research. Scientists speak precisely about technical limitations. Military leaders hear challenges to be overcome. The two groups operate with different assumptions about what is possible. In this case, the gap persisted until the war ended. The Kugo program continued receiving resources until Japan's surrender. The last recorded test was in July 1945, less than a month before the war ended. Scientists were still killing rabbits at 30 meters, still writing reports about incremental improvements, still working on a weapon everyone should have known was useless. After the war, some criticism emerged from Japanese sources. How had resources been wasted on such an obvious failure? Why had no one stopped the program? Where was the accountability? The answers were uncomfortable. The program continued because stopping it meant admitting failure. Military leadership did not want to admit they had been wrong. Scientists did not want to directly contradict military leaders. So everyone continued playing their role. Scientists tested, officers reviewed reports, resources flowed, and nothing useful was produced. This pattern repeated across multiple Japanese secret weapon programs. Jet aircraft that flew but could not be produced in useful numbers. Kamikaze weapons that killed pilots without significantly affecting the war. Biological weapons that were uncontrollable and ethically monstrous. Each program consumed resources. Each delivered little or nothing of military value. The collective waste was staggering. Resources that could have been used for practical improvements to existing weapons were instead directed to programs that could not succeed. Would better allocation have changed the war's outcome? Probably not. American industrial and material advantages were too large, but it might have extended Japanese resistance or reduced casualties. The death ray specifically wasted resources that could have improved radar systems. The magnetron technology used in the Kugo was similar to technology needed for effective radar. Japan's radar systems were inferior to American and British radar throughout the war. If the scientists and resources devoted to the death ray had been directed to radar development, Japan might have had better detection and fire control systems. This would not have changed the strategic situation, but it might have made individual battles more costly for American forces. Better radar meant better early warning, better fire control, more effective use of available forces. These incremental improvements add up. Instead, those resources went to killing rabbits at 30 meters. The opportunity cost was real, not decisive, but real. American assessment of captured Japanese technology generally concluded that Japanese science was competent but poorly directed. Individual projects showed sophisticated understanding of physics and engineering. But at the program level, priorities were often misaligned with practical needs. The death ray exemplified this. Sophisticated microwave technology applied to an impossible mission. If the same scientists had been working on radar or other practical applications, they would likely have produced useful results. Instead, they were directed to build a weapon that physics said could not work. Some post-war analysis has been harsh on Japanese leadership for allowing this, but similar dynamics have affected American military research, projects that consumed enormous resources while delivering little practical value. Difference in degree, perhaps, but not in kind. The death ray story is unusual mainly in how clearly useless the weapon was. Most failed military research programs at least produce something partially useful. Technology that works but not as well as hoped. Capabilities that are helpful in specific circumstances. The Kugo produced almost nothing of value. The microwave technology was sophisticated. But other programs had developed similar technology for practical applications, like radar. The Kugo did not advance the state-of-the-art significantly. It just demonstrated that killing rabbits with microwaves was possible, but pointless. In historical retrospectives, the Kugo is often mentioned alongside other strange weapons of World War II. Nazi acoustic cannons, American pigeon-guided missiles, British ice ships, Soviet anti-tank dogs. Each seemed like a good idea to someone. Each failed to deliver useful military capability. These weapons are interesting as historical curiosities. They show the desperation of warring nations, the willingness to try anything that might provide an advantage, the hope that unconventional thinking would produce unconventional solutions. Sometimes unconventional thinking works: radar, sonar, proximity fuses, nuclear weapons, code-breaking machines. These unconventional technologies changed warfare. They show that pursuing new ideas can pay off dramatically. But for every radar, there are a dozen death rays, projects that seem promising but fail to deliver. The challenge is distinguishing between the two early in development. This is difficult. Radar seemed unlikely to work when first proposed. The death ray seemed theoretically sound. The difference became clear only through testing and development. Radar worked and kept improving. The death ray worked on rabbits and stopped improving. Recognizing when a program has hit fundamental limitations and should be canceled is one of the hardest decisions in military research. Japan failed to make that decision with the Kugo. The program continued long after it should have been obvious it would not produce a useful weapon. Resources were wasted, opportunity cost was paid, and in the end, nothing of value was delivered except a lesson about how desperation can drive poor decisions. The scientists who worked on the Kugo were not failures. They were competent researchers working on an impossible problem. They produced sophisticated technology that worked within its limitations. Those limitations made it militarily worthless, but that was not the scientists' fault. The failure was institutional. Military leadership that demanded miracle weapons without understanding technical limitations. Political environment that discouraged honest assessment of program prospects. Resource allocation systems that could not cancel failing programs. Cultural factors that made admitting failure difficult. These institutional failures affected all of Japan's miracle weapon programs. The death ray was just one example, a particularly clear example because the gap between promise and delivery was so enormous. But the dynamics that produced it affected other programs as well. Modern military research tries to avoid these problems through more rigorous program management. Stage-gate development processes, regular reviews, willingness to cancel programs that are not meeting milestones. These processes do not eliminate failed programs, but they reduce the resources wasted on them. The death ray would likely be canceled quickly in a modern development process. Early tests would show limited range. Technical analysis would reveal fundamental limitations. Program would be either redirected to more achievable goals or terminated entirely. Resources would be reallocated to more promising projects. But in 1943 Japan, no such process existed. Programs continued based on political priority and optimistic assessments. Fundamental technical limitations were either not recognized or not acted upon. And resources flowed to death rays that killed rabbits while practical needs went unmet. That is the real story of the Kugo, not just a weird weapon that did not work, but an example of how institutions can fail at resource allocation, how political pressure can override technical judgment, how desperation can drive investment in impossible solutions. The death ray worked. On rabbits. At 30 meters, that was all. And all the hope and resources and effort in the world could not make it into something more. Physics was indifferent to Japan's need for miracle weapons. The inverse square law did not care about strategic situation. Magnetrons could not produce more power than their design allowed, no matter how desperately that power was needed. The death ray that actually worked. Until anyone needed it to do anything useful. Then it was just an expensive way to kill rabbits.